Imagine spending months engineering the perfect application, only to watch it crash on launch day because of a single hidden error. That tiny mistake cascades into what the industry calls the $100 billion problem. To prevent crashes, developers write test code to verify their actual code. You're effectively doubling your workload just to ensure the original system works. And if you are relying on older, heavyweight languages like Java, this necessary layer of protection becomes a miserable chore filled with repetitive boilerplate setup. Securing your logic should never require building a second, equally confusing labyrinth of software. This is exactly where Python steps in. It strips away the excess, relying on a syntax that reads almost exactly like plain English. Look at this comparison. It takes a dense 15-line block of setup just to test a button. On the right, Python handles that exact test in 3 lines. Because Python is interpreted, you skip the agonizing compiling wait. You write, run, and get instant feedback. When you write less code, you introduce fewer errors into the test suite itself, giving you a faster and highly reliable foundation. Python scales from single-line checks to entire systems, using a massive ecosystem of libraries built for stress testing full applications. The absolute standard for this is PyTest. It requires very little setup, making it highly accessible for developers to start writing checks immediately. Yet, it easily handles extreme scale. It starts with a single isolated unit test and multiplies outward to support complex, multi-layered functional testing across massive systems. Once you verify the backend logic, you need to know how the software handles an actual user. For that, Python uses frameworks like Selenium and Playwright to simulate physical human behavior. These tools pilot web browsers completely on their own, rapidly clicking buttons, filling out forms, and verifying that your user interface looks flawless, whether it is loaded on Chrome, Safari, or Firefox. They allow a single developer to guarantee both the invisible data logic and the highly visible front-end user experience. As these tests get more comprehensive, a communication bottleneck emerges. Technical engineers have to explain the results to non-technical business managers. To close that gap, QA teams deploy the third major tool in the ecosystem, Robot Framework. This operates entirely on a low-code, keyword-driven model. Instead of writing scripts in deep programming syntax, testers construct their cases using plain, readable sentences that explain exactly what the software is supposed to do. This framework makes technical verification accessible to the entire company, providing business managers with clear, readable insights into software health. In modern software development, these scripts are never confined to a single engineer's laptop. They are integrated directly into global DevOps pipelines, specifically the continuous integration and continuous deployment tracks used by major tech companies. The moment a developer pushes code to a repository, it activates a global pipeline. This forces Python to run thousands of automated tests simultaneously. If one test fails, the code cannot be deployed, ensuring total stability before public launch. Testing moves from the end of the development cycle to the very center of the process, acting as a persistent defensive grid. Understanding how to build that automated grid directly impacts your career trajectory. Moving away from clicking through websites by hand elevates you from a manual QA tester to a software development engineer in test, or SDET. This chart shows the difference. Manual QA roles often plateau, but SDET skills correlate with higher salaries and higher hiring volume across the software industry. If you want to secure your code and your career, stop performing manual tests and let Python do the grunt work for you. If you want a step-by-step tutorial on building your very first automation script with PyTest, drop a comment down below. Hit that subscribe button for more tech breakdowns, and I'll see you in the next video. Happy coding!